Okay, we're getting started making a new mosaic tile for the Principles of Engineering Manufacturing class. This is a first draft video. We're going to keep it really quick, so we'll be efficient and get right to it. We're starting with a brand new part in Inventor. There we go. And I have my colors set to Millennium. I'd really recommend it. It's File Menu, Options. Go to your Colors tab, pick Millennium, choose one color. Things are just a lot easier to see. I'd also recommend go to Display, choose Use Application Settings, go to Settings, and turn on Shaded with Edges. It just makes everything look a little better. You can say Apply to that. You can also get your edges from up here in the View menu under Visual Style, Shaded with Edges, but you have to do that on a per document basis. Let's go ahead and get started. We are in a new part. We will start a new sketch right on the front plane. The XY plane looks good. I'll choose a center point rectangle, anchor it right at the origin, and bring it out. Press Escape and press D on your keyboard, and we'll drop a dimension on there. Our actual mosaic tiles this year are a little shy of 6 inches. They're measuring closer to 5.88, so I'll go ahead for that. I'll zoom it out, and I'll just give that an equals constraint on the sketch from the side to the top because it is a square mosaic tile. I'll go ahead and press E for extrude and bring that out 1/4 of an inch, 0.25. That matches the thickness of our actual mosaic tile. So my tile is set. Now I'm ready to do my work to get my picture on there. I'll go ahead and get a new sketch on here. I'd like to bring in an image, and I have one downloaded already, a nice rocket logo I found. So I'll just bring that in, and you can see the image is quite a bit larger than my tile. That's fine, we can fix it. I'll get it placed roughly where it needs to be and press Escape because I'm done. I'll go ahead and scale the image. Choose what you want to scale, pick a base point. I think the origin works well. And it looks like I have some sort of freehand mouse scaling. I'm not sure how that's going to go for me. I'm also seeing a scale factor. For this particular image, I'm going to try a scale factor of 0.6. And the image itself is still a little wider than the tile, but it looks like the graphic I'm going for is about the right size. So I'm going to say done. I can barely see my tile sneaking out from behind it. So on height it looks like we're good. On width it looks like we're good. We'll just go ahead and lay that right on top of our tile. So now I can start sketching and tracing over it. I'll start with arcs, and I want to do the best I can to get close to the image. I'll just click, but it doesn't have to be perfect. Images with too much small detail gets really tough. So little clouds, exhaust plume here, I don't think we'll be able to get, but I think we will get a bulk of this sort of crescent moon-shaped arc, and I'm actually going to bring it out a little bit to keep that a little thicker. It'll be easier to machine. I'll go ahead and get the arc for the rocket. It's important to make sure you carefully choose those end points so that everything lines up and we have closed shapes. I might have misclicked there on that one, so I'll just start that over. Green dot, looking good, and drop it. You can always come back and adjust a little bit if you need to pull things in. Some of the images you find might not be a constant radius arc. It might be multiple arcs strung together, and I think we run into that a little bit here. Let's get some of our straight lines now. L for line on the keyboard will do quite nicely. These shapes are so narrow that I'm worried the cutting tool won't get in there. So I'm actually going to anchor this down here and bring it out quite a bit. I'm going with my own style a little bit on this design, kind of using my base image for a reference, and I may need to take that further back over. Let's try this middle one out to here and down to here. There's no way we'll get anywhere close to that sharp point, but we can do our best to try. And we'll bring this down and just make sure that goes to a green dot for a closed shape. So that's looking pretty good. It's with the spirit of the design. This one's a little wide. Might bring it over. That'll give us a little more room for the middle one. Bring this side one out a little bit. That's looking pretty good. I see another couple of straight lines in here. I'll go ahead and drop in. They might be arcs. They're so small. It's pretty straight. I think I'll just drop that in as a straight line across the bottom of these shapes. That's pretty close to being a straight line here on this shape as well. We'll keep it nice and simple for ourselves. Since this is an artistic design, we're not too worried about the dimensions as long as they're not getting too small. Let's try to bring in some more arcs to finish this off. I'll anchor here and anchor down here, and we can see that's not a real close match, but I think it'll still look great on our design. If we had more time, we could get multiple arcs strung together. I think we are going to need to use multiple arcs here. I think this one ends here. Try to avoid snapping to other things that might cause you trouble in the geometry. So I'm going to just push that back and try to carry this on from here to this line, and that's a pretty close approximation, but I can see these two don't come together real great. So I'm going to try a tangent constraint on those, and let's see what we get. Sometimes they may extend on you, and you have to look out for that and possibly trim your geometry as a result. Let's see what we can do for the other side. We'll start at the point and bring it to about here. It's where that arc ends. And I'll pick it up from there and take it out to the straight line and push it back. That's looking really good, almost tangent just from freehanding, but we can be sure of it if we want to with a tangent constraint. So I just have a few more lines left, or arcs rather, to get all these shapes closed. We'll just anchor it up here. That's such a slight arc, and we'll bring this one back. It's looking good. What I really like about this logo is it has primarily big shapes, big, simple regions. That gets a lot easier to program the toolpaths for, to machine on the CNC router. The detail stuff gets really tricky. Oops, and we'll have to go to a smaller diameter tool to get in there. So I recommend keep it bigger. Remember, an 1/8 inch tool cannot machine anything smaller than an 1/8 inch. So it looks like I have the bulk of my design. I'm going to go ahead and hide the image just to be sure that we're done. And oh, that's a little tough to see in green, but it looks like we got it all. So let's see if these closed shapes will extrude now. And this is why I like the Millennium color theme, because it lights up your extruded regions in red. And it does look like we got them all as closed shapes. If yours don't light up, they're not closed shapes. Go back and check your sketch. So we'll pick all these, and then we'll take it back as an extrude cut. Very important, a distance of 0.1. That is the distance we're using for this project. Our total part is 0.25 thick. We're going 0.1 backwards into the material just to get through that first layer to expose the other color underneath. And I'll say OK. And if you want to be realistic with your colors to see what it'll look like, you can go ahead and set your part. Choose the part and then choose your little color pinwheel. My material is yellow on top, kind of a darker yellow like this. And then all my regions inside, I'll just hold Control on my keyboard and pick all these little pockets. And the color of the inside of my material is black underneath in the middle layer. So I'll just go ahead and bring that down to black. So this is what our finished product should look like, and it's looking pretty good. Let's go ahead to the cam side and get our setup and our toolpaths applied. So I'll jump up here to the cam tab, and I'll do a new setup. Really easy. We just have to pick one corner for our origin. You see the XYZ orb right here. And I'll go ahead and zoom in to this back left corner. And X should be pointing to the right into your material. Y should be pointing away from your material. And Z should be pointing straight up and down. If any of those are backwards, you can fix it on the second tab here. Oh, I'm sorry. Actually, it might be on this orientation drop down. You can select which way is which. If that comes in differently for you, you can pick your x-axis. You can pick your z-axis if you need to. But the way we've set up our model, everything is already good to go. On the second tab, we're just going to say that the material we're making this from is the same size as what we've modeled. So it's going to be a relative size box with no additional stock. Right now you can see we have a little additional stock bigger than our model. For this project, we need no additional stock, and it brings it right tight to our model and puts that sort of yellow box over it. So everything is looking good. We have our cam set up now. We can see our origin is still in the right place. Let's bring in some toolpaths. For this project, because we're cutting so shallow and it's such an easy machining material, HDPE, high density polyethylene, we're just going to use a 2D pocket toolpath. That's really more of a finishing strategy than a roughing, but for this project, for the artwork, it's going to work out nicely. So we'll use the 2D pocket toolpath. We'll pick our tool, give it a second, and this window will launch. Let's make sure everybody can see it here. And we'll choose from all tools by type, and we're looking for a flat mill, and you'll have to scroll down through the list until you get to the 1/8 inch flat. And there will be several showing in here, and there are some differences between them. Something of a medium length should work just fine for this project. It doesn't really matter which one you choose. It won't affect the toolpath for this project. So this one looks good to me. We'll select it. For our speed, the routers you'll be running on are not controlled by the program in terms of speed. That's set manually, but just for your knowledge, we are running about 20,000 RPM on those manual controls. Because this is such a small tool, we'll put our cutting feed rate down to 25 inches per minute. This next field will update automatically. And the rest of the feed rates I'll just tab through on my keyboard. 25, 25, 25. Now the plunge feed rate, that's when we're going straight down in the Z-axis. I'm going to set that to a nice slow 10 inches per minute. So our feed rates are set, very important, and it all looks good. Let's take our way through across the tabs. The next one is our geometry selections. We just need to pick all those pockets, all those areas we're machining. The order is not too important. Just make sure you get them all. Oh, and I'm realizing I missed that circle in my design. We can go back and fix that later. Let's keep moving through our tool paths. The next one is the heights. Nothing else here needs to be checked. You're good. Let's move on to the heights. The defaults will work just fine. 0.4 clearance, 0.2 retract, 0.2 feed, 0 at the top, and very important, the bottom. Oops, it looked like my scroll wheel moved a little bit. The bottom is the selection, or the selected contours, I think is the default. That takes us to the bottom, this black area, the bottom of our pocket where we're machining. If we want to save a little bit of time from cutting air, we can bring this feed height down to 0.1, but it's not a problem to leave it at 0.2. It'll just take a little bit longer. Everything here looks good. Make sure yours matches these. The next tab is our passes tab. This step over is how much material the tool removes in every pass. If you hold your mouse long enough, it'll give you a little tool tip on that. Our tool is only 0.125 wide, 1/8 of an inch. So this would work okay, but we'd like to give ourselves just a little more overlap between our passes. So let's go with 0.075, 75 thousandths of an inch. These other values are okay. Stock to leave, you'll actually want to uncheck. We don't want any stock to leave. We want to machine our entire shape. And the rest of these options are fine. Let's go to our last tab called linking. These options are fine. If you'd like, you can bring in a little bit of lift height. We won't get into the specifics, but a lot of time I like bringing 20 thousandths of lift height. The lead-ins and lead-outs we don't really need, and it can make it tough for the tool to get in some of those tight areas. Let's go ahead and uncheck the lead-ins and lead-outs. For your entry style, a lot of times Helix works fine. For some of these tighter shapes, we might want to go for profile, and I think it'll still helix into the bigger shapes. For your ramping angle, 2 degrees is fine. If we'd like to speed things up just a little bit, we can bring that up to 4 degrees. I would not exceed 4 degrees. And the rest of these parameters are okay. If you're having trouble getting the tool into a smaller pocket in your design, you can try bringing down this helical ramp diameter to something smaller. Let's click OK and see what we get. You see the percentages going here. You'll start to see the tool paths appear as they generate. Sometimes they show automatically. Let's click it and see if we got them. Oh, there they are. Looking good. We actually got a good ways down through our little triangular pocket here, but I notice we're missing this pocket and I'm not sure why. I don't see any tool paths there. If we right click and say show log, I notice there's this little check mark here indicating there's a log. Let's show the log, and it says one or more pockets were not machined because we can't reach them with the given ramping constraints. So let's edit that tool path, right click and edit, come back to linking, and let's try a different ramp type. Let's try smooth profile and see what we get. So the path is regenerating. I already see it got that pocket this time, and we got everything. It looks good. Now let's say something changed in our design. We forgot to bring in that circle. Let's go back to our 3D model environment. Let's go back to our model browser. Let's go back to the sketch where we created that design and edit that sketch. Let's open it up and bring back the visibility of that image. And let's bring back that circle. I'm just going to eyeball the center on this one, and I can move it if I need to. I like it. That looks pretty good. Let's finish the sketch. You might say, where's my circle? You need to edit your feature to adjust your profile for the extrusion. So we'll get that profile selection. Holding Control on your keyboard will deselect as you click and say OK. So we have our circle now. Let's go back to the CAM environment. Excuse me, let's go back to the CAM browser, and you see this red X. Right click and regenerate the tool path. Always a good idea. And everything should regenerate, and it should automatically update to avoid that circle, and we see it's going around it nicely. These little green squiggles, by the way, these are the linking moves, where the tool moves between places that it goes. So everything looks good. Let's run a simulation now. We've selected our toolpath, or better yet, select your entire setup. Let's run a simulation. There's a few options I like. I like to turn off holder. I like to have the toolpath usually as a tail is a nice way to look at it. And by default, this is on material. I like going to operation. And you may need to click that twice. There is a little glitch in the software. You may need to click Operation Colorization twice. Everything's looking good. Let's go ahead and play our simulation. You can see our tool ramping in nicely and then taking out our areas. And I'll go ahead and speed it up just a little bit. If you have a 3D mouse, you can orbit around in this process. And everything looks great. And you see some little orange banding, little striping on there. That's usually just graphics artifacts, or it could be an indication of the toolpath tolerance. Nothing to worry about. However, you do want to look at your timeline down here. If you have any red in your timeline, that is a problem. And that means the tool is crashing, and we need to figure out why. But this all looks good. We can play it again. We can bring it slow. In fact, when you pause, if you just click and drag your mouse left and right, you can really work your way through the details of the machining process. and it all looks good. Let's close and get ready to post-process our G-code. So we're choosing our setup. Post-processing takes these toolpaths and creates the G-code that can actually run our machine. So we'll say post-process, and we get this window. This default folder is fine. That's where the post-processors are located. For our routers in the lab, you'll need to select the type of machine. We don't have a specific post-processor to our machines, but the closest and most universal is going to be FANUC, generic FANUC. It's spelled like FANUC. They've told me it's pronounced FANUC. That rhymes with panic. But don't panic. We're doing well. Output to a folder on your own personal U drive is a good place to store it. I have a G-code folder for myself. The program number is just fine, and you'll need to make one slight change here. By default, the helical moves is yes. I recommend you turn that to no. Our Techno router does not interpret true helical moves. Setting that to no will just change those helixes into a series of straight lines that approximates a helix. All the rest of the operations should be good. Go ahead and give yourself a proper title with your name or your design in there under Program Comment, and Open an NC File Editor is checked. We like that. It's good. Let's go ahead and post our code. It's going to ask us to save it. We want to make sure it has a .nc file format for the Techno router, and I'll just give it a name of Mosaic Rocket.nc for my own project, and we'll save it. And if all goes well, which it has, your text editor called Inventor HSM Edit will open for you to be able to look at this code. Now there's a couple changes we need to make before we can run this code on the machine. Right at the top we have this line that says G28. Unfortunately, our Techno router does not properly interpret that G28 line, or we're not set up for it. So we need to actually remove it from the code. And then if you scroll all the way to the bottom of the code, you'll see all these moves that's making your design. All the way to the bottom, we have two more lines with the G28. Those need to come out of the program. Take them out and save it. So the code is complete. You're now ready to set up on the machine. Just a quick note, if you plan to run your project on the Larkin router, those are great machines. We have the Larkin 4040 and the Larkin 2424. Those machines have been retrofitted to run a control known as Linux CNC, and I believe we have a special post processor for Linux CNC. Let's go ahead and try posting for that. HIJL Linux. Linux CNC, formerly known as EMC2. Those machines actually do helical moves okay, I think. We'll have to check that, but you're probably going to be just fine turning that off nonetheless for this project. Number and name should be alright. We are outputting. Don't use this default. Don't save your programs to the local disk C. Put them on your U drive so you have them to keep, and so we don't clutter our local hard drives. Let's put them on our U drive G-code folder, and it looks good. Let's save it as Mosaic. I'm going to just say Linux CNC so I know this is different. And I forget the file extension. I think it may do that for us. Let's check it out. Okay, so for those Larkin routers running Linux CNC, your extension is .ngc. If we look at the code, everything looks okay right off the bat. However, I don't think we're running tool length compensation. I think we need to change this G43. In fact, we need to just take it out. This way the tool will go right to these coordinates based off what we set. Let's check the bottom of the program, everything looks reasonable here. So only that one change needed for the Larkin routers running Linux CNC. In the beginning of the program, we took out the G43 and we took out the H number. We left the Z.6. So at the end it looked like this. And that's good for the Linux CNC machines, and we'll save that. Do check with me before you get ready to roll, and we'll make sure you have everything set properly on the machine. Thanks for watching the video, and good luck with your Mosaic project.